All right, we're going to start off today talking about some terminology. And last time we talked about the ordered pair x, y. This value gives us the domain. And the y values are the range. But what was new last time was that we talked about this as being the input values. And the y values being then the output. So today the new term is independent. Variable. And the y is going to be the dependent. Variable. Now back in the day, a long time ago, this was a diagram that was given to kids, and this was to simulate some kind of machine that's got these different spokes and cogs and churning and burning type thing. And you put an X value in this machine, and it goes through here and comes out as a Y value. Okay? And that's just a little hook to get you to remember that this is the input and independent. It depends on what you put in this machine as to what you get out. It depends on what you put into that machine that you get out. And we do several things. This machine represents a table of values. And you have seen a table of values before, I think, where you have X values and you have Y values, and there's some kind of rule minus up here where you have values of 5 and -2 and 7 and 1. And anytime you substitute a number in for a variable, you're to put it inside of parentheses and then follow PEMDAS. Your order of operations, parentheses, exponents, multiplication and division, then addition and subtraction to get this value. Well, this 2x plus 8 is what this machine represents. It's multiplying and adding to get a value of 18 out at the end. So I have 2 times -2, which is -4 plus 8, which is 4. 7 times -2, -14 plus 8 is -6. And again, this is what I should have 2 times +7 here, not 14. Should have a value of 22 over here. These are independent values. These are values that you choose to put into the machine. And you get values coming out. Now each of these values then, the input value and the output value can be then made back into that ordered pair. When x is this, y is that. When x is 7, y is 22. When x is 1, y is 10. So we will be able to check and select these independent values. But primarily, what we always like to do is we want to know what's happening to the graph, most importantly, right around the origin, right around this area. So we typically choose values between -3 and 3 for our x. Typically choose values between -3 and 3 for our x. Now we may be required or need to select additional values, but this generally gives us a pretty good idea and purpose. The other thing is our papers only go to 10 on each way on the grid, so we got to have most of our stuff right around here. Okay? So again, taking some review from a previous section, we're going to review what it means to call something a function. And remember, that is very simply each x value has exactly one y value. And that graph, the graph must pass the vertical line test. Has to. Specifying a special kind of function we're going to call it a linear function. A linear function is the graph of a non-vertical line. Why non-vertical? First of all, let's talk about linear. Linear says line. Function says passes the vertical line test. A vertical line would be this, and guess what? That doesn't pass the vertical line test. This fails the vertical line test. And that's the reason it can be a graph of a non-vertical line. Because all of our other graphs all pass. Even a graph with a slope of 0. So, starting again, a linear function is a line but not vertical. It has a constant rate of change, which is the same as saying it has a constant slope. Rate of change is slope. And we know that each of these lines has the same rise and run, rise and run, rise and run, rise and run. That's how we get them on the graph. These lines all can be written in the form of y equals mx plus b. Where the exponent on x is equal to 1. This is y equals mx plus b. That is a 1 right there. And if we didn't know already, an exponent of 1 is equal to the first degree. First degree equation when it has an exponent of 1. And I'm going to briefly describe some other graphs to you, so you can understand, because the key point here I'm going to make is that each degree has its own shape. Each degree has its own shape. Y equals x squared is a parabola. And a parabola is the shape we talked about the other day, where you are looking out the back of a boat. And this is going to get wider and wider and wider. Y equals x cubed has the shape of a snake. Y equals the absolute value of x is one we talked about the other day as well. and that's the shape of a V. And y equals the square root of x. To me, it looks like the Nike symbol. Got a little bit of a swoosh to it. Upside down swoosh, maybe. Now, the point is that these graphs, when I see x squared, I know it's a parabola. When I see x cubed, I know it's going to be a snake. When I see absolute value, it's a V. When I see this, it's a little hook on it. This graph can be moved down, left, right. It can be made to open up or close together. The same with these. And this graph of absolute value, we can open it up the V, we can close down the V. We can do that by changing numbers, but the number that remains constant, that tells us the most information, is the exponent. Each equation has its own shape. You'll notice too that these are all functions. They pass the vertical line test. The one we have to be careful of is the line that is vertical. These are not going to be vertical, they're all going to pass. Lines are all functions except for the vertical line. It is the one that is not a function. Okay? Are we cool with that? All right. So, what is a linear function? Let's go right here. A linear function, it's code, it's in code. It is a function, I'm sorry, it is a line that is a function. It is a line that is a function. These down here, are they functions? Yes, they are. Are they lines? No, they're not. So we get technical with these. And we name these, examples of these, as non-linear functions. Not a line, but yes, it's a function. It passes the vertical line test. Does that make sense? Not a line, but a function. It passes the vertical line. As I pass the vertical, this ruler across here, it does not touch the graph in two places. No matter where I'm at, it only touches the graph one time. Okay? All right. So, This is stated when we talk it f of x. And it means a function of x. It means a function of x. It means the graph will pass the vertical line test. It means it will pass the vertical line test. Before we would write y equals 2x minus or plus 1. Now, because I know this is a line that's not a vertical line, I will write f of x equals 2x plus 1. Y equals x squared. Now can be written as f of x equals x squared. It simply says this has already been checked out, it's been validated, the graph is going to pass the vertical line test. And each of these functions, and these are all functions here, they're non-linear functions because they pass the vertical line test. So I can technically write them all as f of x equals x squared, f of x equals x cubed, f of x equals the absolute value of x, and f of x equals the square root of x. It says all of these are vouched for. They are functions. They are going to pass the vertical line test. And the other point of emphasis is, again, I want to first of all saying, hey, y equals and f of x equals, same thing. The second thing is, each of these exponents gives me a specific picture to go from. Okay? All right. So, taking out your sheet of graph paper now. And walking through some of that. If I write out y equals x, y equals x. Does everybody agree that this is the same as y equals 1x? 1 times anything is that thing. What about that? Adding 0. Adding 0 to that thing is that same thing, right? It's a property of 0, property of multiplication of 1. The reason for this is that this is now in y equals mx plus b form. This equation is now in y equals mx plus b form, where my slope is 1 and it's constant, and my b value is equal to 0. Also, This is an exponent of 1. If it's not written, it's understood to be 1. X to the first is equal to a first degree, which means it is a line. So if I didn't know it before, by expanding it out into mx plus b, I should have known it right away when I had an exponent of 1. So as I graph this, I'm going to start at 0, and my slope is constant. It's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. I'll get a few points there, and then I'm going to draw my line. For the graph. It is a line. It does pass the vertical line test. Each x has one and only one y value. So I can say this is the same thing as f of x equals x. Y equals x, f of x equals x. On the second graph, if I say y equals 2x plus 1, I know my slope here is 2 over 1, and my y-intercept is 0, 1. So I'm going to start at 1. I'm going to rise 2, run 1, rise 2, run 1, rise 2, run 1, and then I'm going to draw my graph. Some talking points for the day. X is in the first degree. This is a line plus the fact that it passes the vertical line test means it is a linear function. It is a graph of a line, and it passes the vertical line test. And finally, I can write it as f of x equals 2x plus 1, just as easy as y equals 2x plus 1. y equals x squared minus 3 is the next equation. Now, we've talked about this is not degree 1 anymore, this is degree 2. And if it's a degree 2, it's a parabola, which means its shape is going to be that looking out the back of a boat. And it could also go upside down, depending on whether you're going up the river or down the river. The shape could go either way. We are going to use a table of values. And we, again, as I said before, we try to figure out what's going on in this area. So we're going to use x values from -3 to +3 in our table of values. We're going to -3, -2, -1, 0, 1, 2, 3. So we have -3 squared, -2 squared, -1 squared. I am taking the 1 and the -2, -1, -2, -3 and substituting them in for x. Always use parentheses when substituting a number in for a letter. It'll keep you from doing some dumb stuff. And you'll be happy that you did. Okay, so zero squared minus 3, 1 squared minus 3, 2 squared minus 3, -3 squared. Okay. -3 squared does not equal -3 squared. You have to use parentheses when you substitute. -3 times -3 is +9. This says the opposite of 3 squared. Exponents act on what's directly in front of them, so the answer here is -9. Those two are not equal. If you punch it into your calculator, make sure you put those parentheses in there, or you're not going to get accurate information. -3 squared is 9, minus 3 is 6. 2 squared is 4, minus 3 is 1. -1 squared is 1, minus 3 is -2. 0 squared is 0, minus 3 is -3. 1 squared is 1, minus 3 is -2. 2 squared is 4, minus 3, which is 1. 3 squared is 9, minus 3, which is 6. You're now going to plot these points on the graph. -3, +6. -2, +1. -1, -2. 0, -3. 1, -2. 2, 1. 3, 6. My domain here, ladies and gentlemen, is anything I want it to be. These are discrete values, but I am going to take and I am going to plug these in and I am going to connect these dots. Looking at the graph, does my vertical line touch the graph at 2 places anywhere along the way? Does it touch it at 2 places? No, only touches at 1 place at a time, correct? So that means it's a function. This passes the vertical line test. This is a nonlinear, which means it's not a line, a nonlinear function. A nonlinear function. Take the 2 pieces. It's not a line, and it passes the vertical line test, so it is a function. This one, if you want to, is a linear function. It is a line. And remember, our notes said that we had to have a constant rate of change. Well, that's what's demonstrated here. Up 2 over 1, up 2 over 1, up 2 over 1. On this graph, I would go up 1 over 1 to get to the next point. And then I got to go up 3 and over 1. And then I got to go up 5 and over 1. That's not consistent. That is not consistent. Starting here, up 1 over 1, up 3 over 1, up 5 over 1. Those are not consistent slopes. Those are stair steps that get steeper and steeper. They change. So it's not linear because that has to be consistent on a line. It is a function. No, it's non-linear. It is a function because it only touches the graph in one place. Is everybody cool with that? Cool with that, I should say. All right, on your back side of your paper. On the back side of your paper. We're going to do a couple of those other graphs just to show you and prove to you they are functions and their shape is different. I have y equals the absolute value of x plus 1 minus 3. We are going to start with x values, -3, -2, -1, 0, 1, 2, and 3. My rule is x plus 1 minus 3. And I'm going to substitute using parentheses the absolute value of negative 3 plus 1. The absolute value of 3 plus 1. Now remember, PEMDAS, and for those of you who are new, again, I'm not trying to talk down to you, I'm just trying to make sure you're on the same page. This involves parentheses, brackets, square root signs, and absolute value signs. These are all P in PEMDAS. They're all the P in PEMDAS. They're grouping symbols. And by that means I will do what's inside of them first. So I have negative 3 plus 1, that makes negative 2, but the absolute value of negative 2 is a positive 2. And positive 2 minus 3 is a negative 1. Substituting in here, negative 2 plus 1 is a positive 1. I'm sorry, is a negative 1. The absolute value of that is a positive 1. Positive 1 minus 3 is a negative 2. Substituting negative 1 over here, negative 1 plus 1 is 0. Absolute value of 0 is 0 minus 3 is a minus 3. Zero plus 1 is 1. Absolute value of 1 is 1 minus 3 is a negative 2. 1 plus 1 is 2. Substituting using parentheses always. Absolute value of 2 is 2 minus 3 is a negative 1. 2 plus 1 is 3. Absolute value of 3 is 3. Minus 3 is 0. 3 plus 1 is 4. Absolute value of 4 is 4. Minus 3 is a positive 1. So now I get to graph all of these. I have negative 3, negative 1. I have negative 2, negative 2. I have negative 1, negative 3. I have 0, negative 2. I have 1, negative 1. I have the point 2, 0. And I have the point 3, 1. So if I connect these dots, do I get the shape I'm supposed to have for an absolute value problem? Well, the shape I'm supposed to have is this V shape right here for absolute value. Does it look like it's going to be a V shape? Yeah, pretty much. I'm just going to connect these points out this way. And I'm going to connect these points out this way. And that is my shape. Is it linear? No. This is a negative slope, that's a positive slope. A line has the same slope all the time. Is it a function? Yeah. So this is termed this is a nonlinear function. Non-linear function. Okay, last one. We're going to go through this a little bit quicker. F of x is equal to x cubed minus 1. Now, I want to go back here. First of all, I should have finished this up. I got in a hurry. This, too, can be written using function notation. F of x equals the absolute value of x plus 1 minus 3, because it passed the vertical line test. As opposed to this one over here, who we're straight up going to tell you before we ever get started, hey, this is going to pass the vertical line test. It has an exponent of 3, not 1. So this is going to be not a line. It is not a line. If it were an exponent of 1, we'd say it's a line. This is a non-linear function. Okay? So I have f of x is equal to the x cubed plus 1. I again going to have some values here. My rule is x cubed plus 1, negative 3, negative 3 cubed plus 1, negative 2 cubed plus 1, negative 1 cubed plus 1, 0 cubed plus 1, 1 cubed plus 1, 2 cubed plus 1, 3 cubed plus 1, anybody know what negative 3 cubed is? Negative 3 times negative 3 times negative 3 is negative 27. Plus 1 is negative 26. That sucks, because I can't use that point, because I don't have negative 26 up here. I got negative 10. Negative 2 cubed. Negative 2 times negative 2 times negative 2. Negative 8 plus 1. Negative 7. I can get that on the graph. Negative 1 cubed. Negative 1 times negative 1 times negative 1 is negative 1. Plus 1 is 0. 0 cubed plus 1. 1 cubed plus 1. 2 cubed is 2 times 2 times 2 plus 1. Getting cottonmouth. Is 9. 3 cubed is 27 plus 1 more is 28. And again, that's crap because I can't use 28. But I do have these points to put on the graph. Negative 2, negative 7. Negative 1, 0. 1, negative 1, 0, I'm sorry, 0, 1. 1, 4, and 2, 9. I am going to connect these dots, and when I do, it's going to look like a snake. Again, the graph does not demonstrate a line, so it's definitely nonlinear. And when I take my ruler across it, I only touch the graph at one place at a time. So therefore it is a function. So we got lots of stuff today, and some of it's just stuff. Okay? We got terminology, independent, dependent variable. We have a table of values where we're trying to find the values right around the origin. We've differentiated about a linear function versus a nonlinear function. If it passes the vertical line test, it can be a function. If it's a straight line, it's a straight line. I want you to understand that each degree has its own shape. Doesn't matter, we only got a couple of them on here, but there's a bazillion of them. These are nonlinear because they are not lines. So they're nonlinear functions. Give me just a minute, folks. Give me just a minute. This is important stuff. When you are filling out a table of values, you must use parentheses. If the graph crosses or passes the vertical line test, you can substitute y equals and say f of x equals and call it a function. If they tell you it's a function straight up, then your graph better model that the fact that it's a function. It will not change the values you choose. You're still choosing those values between -3 and 3. Are there questions here? Do we need homework here? I don't think so either, but I appreciate your attention. Make sure you understand there's going to be a quiz on Thursday.